So a pretty cool thing about HDZero Goggle is it's an HD digital goggle that also has support for analog. And it's not just basic support for analog input, it actually supports a module that we can clip onto the side of the goggle and give us basically native analog support. And it's able to actually improve the video quality of analog by using a 2D deinterlacer in real time, adding no delay. And what that deinterlacer does is pretty interesting. It's combining the two fields of the analog signal in order to create more vertical resolution while we're flying in real time. And I'll be going through and showing you some side-by-side examples of what that looks like up against a pretty good Sky04x 60 FPS DVR that doesn't have this deinterlacing feature that I'm talking about. And the really cool thing about the deinterlacer is it's happening in real time. There are DVRs out there that will, in post-process, in the DVR process, deinterlace the video, but it won't do it in real time in the goggle feed. And what you're going to see with a good deinterlaced signal is, of course, a little bit more vertical resolution and also a nice stable image that's not moving up and down. It's going to be hard to see this unless you are watching at the highest quality on YouTube. So that's going to be, I think, 4K 60 FPS. Trust me, you're going to want to get that frame rate and that resolution pumped up in order to really see these differences. So without further ado, let's get into it. Let's take a little closer look at this module and how it works, and look at some of the example video and explain how it's all working. So to install this, all we have to do is take the HDZero Goggle, and then there's the success report on it. And then I'm going to line up this little U shape right here that protects the pins with the little slot right there. And then you just push it into place. And then when you want to take it off, you pull it off. It's held in with a clip. It can be hard mounted on there if you need it to be held more securely. Let's take a look at the inside of this. You can see there is no wasted space on this. On the inside, there's a circuit board. On this circuit board, there's an analog pin pass-through. You can kind of see it on the back side there too. And this board also has the Wi-Fi chip on there to be able to stream video to your phone or connect the goggle to the internet. So you just line up the pins here. Let's see if I can get that on video. You just line up the pins and push it in like that. And you can see there is no extra space in there. This is literally as slim as this design could have been made. And then we, of course, put the vanity cover over top of this. And it does work with more than just this rapid fire module. Works with any module that's designed for a Fat Shark style bay. And then there is a little bit of excess here. It's kind of unavoidable due to all these having a little bit different overhang amounts. So again, I'll just clip that on like so. And then that's what the goggle looks like with the analog module mounted onto the side. Works pretty slick. I've slowed this down to quarter speed so you can see the shifting up and down of analog DVR on the left. And on right is HDZero with the deinterlacer. Keeps things nice and smooth. Now this is 1x speed, so you can't really see that shifting up and down sometimes, but if you slow it down you can see it. And keep that in mind as we watch the rest of this video. Another thing to point out is there are some flashes on kind of like sync loss. You'll see it right there. That's all getting worked out yet. Focus on edges of the picture that's where, or things further off in the distance, and that's where you're going to be able to more easily see the difference in detail. Now I think this one shot here sums up everything. You've got jumping up and down, kind of blurry on the left, and then you have smooth on the right. And then take a look at the roof line. The roof line is stair step on the left and nice and smooth on the right. So it's the little details like that that you might not notice while you're flying, but once you know where they are, it's hard to unsee it, and you can see where the benefits of this deinterlacer is really helping improve analog image quality. I think the finer details have more contrast also. I don't know if that was just a tuning option that Carl's doing, but with analog it's a composite video, so the luma and the chroma are merged together, and then you got to kind of dissect that and pull it apart in post, or when you're decoding it. So I think that's kind of a choice. That's why the one on the right is a little bit more punchy. Take a look again at the jagged roof edge on the left, smooth on the right. You can see like round objects are more round. Angled objects are more clean looking. You can see things that are fine a little bit easier, like that chain. It's these small details, things further off in the distance, smaller edges, hard edges. That's where you're going to notice this improvement in analog video quality. It's been pretty interesting testing analog again. You do definitely get spoiled by digital and how much more stable the image tends to be. And there's my daughter. She was helping me test today. Next, I want to look at a phenomenon that I saw when I was looking at this video. On the SkyZone DVR, the image would move up and down, and then the OSD element would appear to stay fixed. And then on the HDZero DVR, the image would stay fixed, which is usually what you want. You want the image to not be moving up and down, but the OSD would actually move up and down. And I wanted to figure out why this was happening, and if you look, every analog system that we use for drones has this Maxim chip installed that does the on-screen display that adds characters overlaid over top of the analog video feed. And that's got a 12 by 18 pixel character size. And if we look down here, you can see how it works. You've got the video input that comes in scan line by scan line. And then a chip on this is kind of inserting every scan line another part of a character for the on-screen display. So you got scan, 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 and it's overlaying characters as it goes. And then you have video output here. And if we skip down to page 10, we can see basically the amount that it's able to write in characters. So on NTSC, it allows for 13 rows by 30 characters, and on PAL it's 16 by 30 characters. And the reason it's 13 rows on NTSC is that the pixels are 18, or the characters are 18 pixels high. So if we take 240 scan lines and divide it by 18 pixels high, we get about 13 characters. And that's your answer right there. It's doing this per field, each field having about 240 lines to work with. You divide that by 18 pixels high for each character, and you get 13 of these rows. And that confirms also that this is writing every field, and that means that it's going to be shifting up a little bit on one field and then down a little bit for the second field. So the character should be moving up, down, every field. Here's that video clip again of the Sky04x on the left and then the HDZero Goggle on the right. You can see the OSD moving up and down on the HDZero Goggle, and I put a reference line there so you can see it. And then if you follow that across, you can see that the SkyZone one is staying fixed. Now, this is pretty interesting, and you can tell what's going on if you look close. The whole image on the Sky Zone one is actually moving up and down. And that's because with the Sky Zone DVR, it's showing you what you actually see in your goggle screen, which is an image that is moving up and down every field, causing a bit of a blur to happen. And on the right, the deinterlacer is keeping the image nice and steady. So if you look at the line on the right-hand side on the upper right, you can see it's not really moving with respect to the holes, but on the left, it is moving up and down with respect to the holes. Also, if you look at the holes, the perforations in front of you, they're more round. They're just definitively better looking round holes. In the image on the right, and then the image on the left is kind of blurry. And I guess that's sort of what I'd expect when you have half the vertical resolution to work with. Also, I imagine the encoder for the DVR is struggling a little bit harder with the image on the left because the content is moving up and down every stinking frame. So I know which image I want to be working with. I want to work with the one that is more stable and isn't moving up and down on the right, even if the OSD is going to move up and down. So the results look pretty good to me. When you look at the fine details, it really stands out. The combination of the image not moving up and down and being nice and stable with also gaining noticeably more vertical resolution is really great. I still need to measure the latency difference of the HDZero goggle with this deinterlacer versus a traditional analog input goggle like the Sky04x. So I'll make sure to do that and let you know how that went. But just flying it myself, I didn't notice any difference in latency, so that's good. I did let Pretty Fast Racer try out the HDZero goggle with analog yesterday. He did notice that there were some blank out periods of maybe black for 3 frames when the signal got low. That's going to get sorted out, and it is a pretty big issue right now. But that's just how things are when you have a system that's still under development. I think at this point it's going to get resolved, and it's looking really good. Getting a free upgrade on analog image quality by using a digital goggle, the HDZero goggle. It's win-win. So you get the HDZero goggle if you fly a lot of analog today, and you get a little bit of a bump in image quality, and then when you're ready to move to HDZero for more quads, you've got HDZero receiver built in. And heck, if you have an HDMI VRX from another company, you could even mount that to the front of the goggle and plug it in over HDMI input. So that's all I've got for today. Have fun.